Polyplex Corporation Limited commenced manufacture of biaxially oriented polyester film in the year 1988. It currently has 2 production lines with a capacity of 15,000 metric tons per year. The manufacturing facility is situated at Khatima in the foothills of the Himalayas, 300 kilometers north of the capital city of New Delhi. In a short span of 12 years, Polyplex has emerged as an internationally competitive company with a global reach. Polyplex exports almost 60% of its production to various customers in USA, Europe, South America, and the Middle East. Polyplex's long-term vision, focused marketing strategy, customer orientation, and relentless pursuit of operational excellence has made it one of the few polyester film manufacturing companies in the world with a track record of growth with sustained profitability. Polyester film is a high-performance biaxially oriented plastic film characterized by high tensile strength, excellent dimensional stability, low moisture absorption, and retention of physical properties over a wide range of operating temperatures. Excellent electrical properties, good optical clarity, and recyclability makes polyester film a preferred substrate over other alternate plastic films. Though polyester film has numerous applications, these can be broadly classified into photographic and imaging films, films for magnetic media, flexible packaging films, electrical grade films, and films for a variety of industrial applications. Polyester film is produced from polyethylene terephthalate, PET, melt-phase resin, the same basic polymer that is used in the production of polyester fibers, PET bottle-grade resins, and PET engineering resins. PET melt-phase polymer is produced by polycondensation of ethylene glycol with either dimethyl terephthalate, DMT, or purified terephthalic acid, PTA. PTA and MEG are reacted in an ester interchange reactor at high temperature to form a monomer. This monomer is further polymerized in a polycondensation reactor at precisely controlled temperature and pressure in the presence of catalysts to form polyester resin or polymer. Additives are added during polymerization to manufacture different kinds of polymers. These resins are stored in different silos. Feeding system transfers the polyester resin from the silos to a mixing system, wherein various kinds of chips are mixed in precise proportion to achieve the desired optical, slip, and frictional properties of the film based on requirement of specific application or customer. The mixed resin is then conveyed to a crystallizer and then through a drying system to bring the moisture content to below 20 parts per million level to avoid hydrolytic degradation of the polymer. Fully dried chips are then melted and mixed in a multi-zone extruder. The temperature and pressure of the extruder is precisely controlled to ensure homogeneity and stability of the melt. The molten polymer is passed through a 2-stage filtration process. The filtration system and the filter media is designed with high-tech metallic media filters of extremely thin microns to ensure removal of impurities. The filtered molten polymer is pumped through an autoflex die onto a chill drum surface where cast film is formed. Uniformity and stability of this cast film is controlled by a high-voltage electrostatic pinning system. The autoflex die uses thermal expansion and contraction of the die lip unit for controlling the cast film gauge profile to high accuracy levels. The die unit is integrated with an automatic gauge monitoring and control system. This cast film is in an amorphous form and is of limited utility. Hence, the film is stretched or oriented in biaxial direction. This orientation process is fundamental to imparting strength, thermal stability, and barrier properties to the PET film. The first stage of stretching or orientation is in the longitudinal or machine direction. The film is stretched by the use of differential speed stretching rollers and infrared heating. The stresses in the structure caused by this orientation tends to align the molecular chain segments in the machine direction. The monofilm then enters the multiple zone transverse direction orientation oven. This oven consists of two continuous chains which run on a progressively divergent and convergent track system. Both the edges of the monofilm is gripped by the chain clips and then pass through various zones. The film is first preheated to improve the mobility of molecular chain and then stretched by divergent movement of the chain on the tracks. The film is heat set and relaxed to stabilize the biaxially oriented film. The temperature and stretching pattern in this process determines the mechanical and thermal properties of the film. The biaxially oriented polyester film then passes through a set of rollers onto a sophisticated auto turret winder. This winding process is continuous and the changeover of master rolls, loading and unloading, is fully automated. The master roll is then taken to the slitting section, which consists of state-of-the-art primary and secondary slitters. The master roll is slit into smaller rolls with various combinations of lengths and widths as per the specific requirement of the customer. Slit rolls are packed and palletized online to specifications based on customer request and logistic demands. The material is then dispatched to Polyplex's customers worldwide using a dedicated online delivering monitoring system. The technologically intensive nature of polyester film processing and a demanding global customer base requires an integrated manufacturing process control system. This system is fully automated with state-of-the-art instrumentation and process logic control systems to ensure effective monitoring and control of more than 200 critical process parameters. Polyplex has assertively and consistently followed its quality policy, customer relationship through consistent quality, committed service, and continuous improvement in each sphere of activity. The quality assurance system is designed around the key features of standardization, customization, conformance, and continuous training and improvement. Polyplex was the first polyester film company in India to achieve ISO 9002 quality system certification. In order to further consolidate its global competitiveness, Polyplex has instituted a new initiative in total productive maintenance in collaboration with the Japanese Institute of Plant Maintenance to achieve operational excellence. Polyplex has set up an environment management system that is in line with the ISO 14000 EMS requirements. It has taken up various community development programs and also runs a school for children of the local community. Polyplex cares for its people, community, and environment, and its role as a socially committed and environmentally responsible corporate citizen.